John Schreckengast, otherwise known as Schreck the Tech, holds a BS degree in Industrial Automotive Technology. He is an ASE Certified Master Automotive Technician. He is also ASE Certified in L1 Advanced Engine Performance, P2 Parts, X1 Exhaust, and he is also an Undercar Specialist. John is also a member of the Society of Automotive Engineers. In the past, John owned and operated his own shop in Aurora, Colorado. Presently, he is employed by Gates Corporation. He has also performed research for Ford Motor Company and Michelin Tire. Hey Shrek, how's it going?
Hey Mark, how are you?
Oh, pretty good this morning. How you doing?
I'm doing fine.
What's going on here?
Oh, well, I was just reading an article this morning that told me that the #1 cause of vehicle-related breakdown on the side of the road is cooling system related.
Really? I had absolutely no idea.
Yeah, it's not engine mechanical or transmission or even flat tires. It's all to do with the cooling system.
That's pretty amazing.
Belts, hose, overheating conditions, thermostats, water pumps, all those issues are causing vehicles to break down. And I think there's a lot of education to be done out there in ways we can prevent this from happening.
Certainly sounds like it. Let's have a look.
Okay.
So John, what about coolant concentration and freeze point?
Mark, I think one of the reasons that it's gotten so bad in the last decade for vehicle breakdowns related to cooling systems is simply because the cars are much more demanding on cooling systems than they ever were in the past. If you think about, like sports cars, Corvettes over here, lower profile vehicles, they have very small openings for the radiator. I mean, you can't hardly even see a grill area on that car.
Definitely. Yeah,
even some of the economy cars are the same way. They're trying to, get a lower profile for better wind resistance. The engine compartment itself is smaller, so the heat doesn't have any place to go. So what happens is even with those complications, now they're even demanding more power out of the engine as well.
And putting more stress on it at the same time, it sounds like.
More stress, more heat, more performance that they want out of the car. And it just makes it harder for the cooling system to do its job, and it makes it more critical for it to be exactly maintained properly while it's running down the road.
So how can we test the engine and make sure we're getting good performance from the cooling system?
Well, there's a lot of tests that we can do. I could start out talking about some of the more basic tests.
Okay.
I think probably one of the most basic tests there is people say, I want to get my car winterized before winter, or I want to get it, summerized before summer comes along.
Yep, the annual rite of spring, and take your car into the shop and get it ready for the summer vacation.
Check it out. I don't want to get stuck in the snow. And I think probably one of the most common tests they do is to check the freeze point of the coolant, probably with a hydrometer.
Floating ball squeeze?
Yeah, the ones that you've seen the technicians grab and they squeeze them.
I've seen them.
I've got a couple here I can show you. I was just kind of playing with them here this morning. Here's a real basic one. They just kind of stick it right in here in the coolant, and then they notice that there's a certain amount of balls that are floating inside this hydrometer. Mm-hmm. Well, the floats indicate on a scale here of what the freeze protection is, and we can see there's 4 balls floating. So if you turn it to where it says 4, it says that this coolant is protected to -25 and probably has a boil-over protection of about 2¼ Fahrenheit. The problem with hydrometers like this is they're not very accurate.
So is there a more accurate, better?
Well, there are, but let me show you first what I mean by not accurate. If I take another kind of hydrometer, now these are both supposed to do the exact same job here.
Are these both hydrometers?
These are both hydrometers, yeah. Now you can see this one is indicating on the Fahrenheit scale for boil over, it's well over 270 degrees. That's vastly different from the 225 that we just saw. And then on the freeze point, it's showing over here better than -45, 50 degrees.
Once again, a pretty substantial difference.
You've got 2 different opinions here from just 2 pieces of equipment. One of the reasons is that these floats that are inside are not standardized. That they can try to use anything to try to measure specific gravity, which is really what we're measuring here. And specific gravity, the one interesting thing about hydrometers is it has to be temperature corrected.
I did notice that this engine is cooled to the touch. Will it affect this test?
Yeah, it will, because this is sitting at room temperature. We haven't been running it here recently. So the temperature has to be corrected for this sample. And I don't think most technicians realize that you have to do a temperature correction on this. What's going to happen is they even make some that have a little thermometer on them. Well, if I took a reading at, say, 70 degrees and then another reading at, say, 100, 110, I could be off as much as 30 degrees on my freeze point. That's drastic.
Once again, a pretty substantial difference.
And that's the difference between being okay and not being okay going out of the shop. And that would be really bad. You know, I was talking about the different kind of coolants that there are. I've got a few samples here of, this is a propylene sample. This is a DexCool sample, which is an ethylene-based coolant. And then I also pulled one out of a little four-wheeler, one of those little ATVs. And I like to talk about this sample because it's over-concentrated. And when I mean over-concentrated, it's pretty much straight ethylene glycol coolant.
That one I noticed is a lot darker. It's not as transparent as the others.
Well, let me show you what happens when I use one of the hydrometers on this. This hydrometer, I can pull up in here, all the balls are floating. Well, on this scale, the only thing it tells me is it's good to -40. What it doesn't tell me is that it's over-concentrated. Right?
No, it certainly doesn't.
Yeah, so the issue there is over-concentration is going to destroy the hoses. Roadside breakdown.
I always thought the higher the concentration, the better.
No, in fact, water disperses heat very well, but we need these extra additives in the coolant so that you don't get corrosion inside the system and you have a better boil-over protection. So we want a mixture, but we don't want it to be too high. We want it to be about 50%.
I think a lot of people forget about boil-over, and I always think of, you know, coolant, antifreeze, protect the engine at low temperatures, but it also serves the other purpose of not boiling over the engine and cooking it.
Yeah, it's kind of a misnomer when they just call it antifreeze. I want to show you what happens when I put this on the refractometer. Now when I look in here, it doesn't even show up on the scale. It's completely off the scale, which tells me it's straight antifreeze. So now I immediately look in here and I know I've got a problem. This is too straight. So if this, using this tool will now help me prevent a roadside breakdown. Now I'm not going to be eating those hoses and destroying the system.
After you've done these tests, what would you do next?
Well, this is just one test. There's a better tool, and that's called a refractometer.
Now, is this something new? I haven't heard of that.
Well, they've been around for years. They've used them in food industry, and chemists use them all the time. But as far as being in the aftermarket for every technician to use, I think we're kind of making them available at an affordable cost here for everybody. This is a very accurate tool. In fact, it's the most accurate way of checking cooling system concentration.
Really?
And it's extremely easy. The nice thing about this is it's automatically temperature corrected, so you don't have to worry about the temperature of the sample. And this will do two different styles of coolant. It'll do ethylene and propylene. And there's two different kinds of coolants out there today, and they're all made either ethylene or propylene based. A hydrometer will not check propylene. So this is a better way to go. Let me show you how it works.
Okay.
We just basically take a few drops of the coolant and we spread them out here on the refractometer. We close this little lens and we hold it up to the light and look through it. Very visual test. Now this is telling me that by the ethylene scale that it's 56% concentration and it's protection of -56. So this is the most accurate way of knowing what the coolant is, and it's very easy to read. Very easy scale inside. In fact, I've seen other refractometers that are very difficult to read. You hold them up, you can't see through them, they're dark. This one actually focuses. It's a great tool.
Great. It obviously works indoors. What about sunlight?
Outside is even better. You know, the better the light, the better the tool. But this works in really low light conditions. It's got a nice shade of blue on the outside. Now the way this works is called a refractive index. And the refractive index is basically, you remember those old prisms we had in school that they would show us how the light,
put the rainbow on the
it would bend through it. Well, this is very similar. It uses the same principle. The light actually bends through the sample that's on there, and it changes where it hits on the scale.
Gotcha.
So it's exactly right. Nothing can affect it, nothing can change it, because it's determined on the speed of the light coming through.
Doesn't matter what the room temperature is, engine temperature, that's great.
Yeah, so I can check ethylene and propylene with this, and I can be right every single time, and I can even take this out and show my customer immediately what their reading is. Very visual tool. I like it.
Great.
Mark, what I'd like to do now is talk about electrolysis.
Okay, what is that?
Well, electrolysis is something I refer to as electrical currents that flow throughout this whole engine compartment. They're flowing through here all the time, and if they get a weak ground or something like that, it will actually flow current through the coolant itself.
Now you mentioned accessories. What type of accessories are we talking about?
Well, any electrical accessory can do this. I mean, it can be the cooling fan, it can be the blower motor for the heater, it can be the starter itself, headlights, anything electrical through this system that happens to have a weak ground will try to find another path. You've heard of the path of least resistance.
Yes.
Well, that can find its way actually through the coolant itself because coolant can be conductive. Now, it's not always just a bad ground. Sometimes it can be old coolant because coolant has properties in it to protect the engine from electrolysis. Sometimes it coats the inside of the engine and protects it from transferring current. But in many cases, it's a weak ground or something that's been installed improperly, like maybe stereo equipment or something like that.
Now, would different metals or composites affect this at all?
Yeah, in fact, dissimilar metals will cause a problem with that as well. And we have a situation here where we have aluminum heads, brass radiator, copper radiator, something like that, and it's kind of like an electrical plating process. And what happens is it will actually take some of the metal from the weaker material and transfer it to the other areas. So what happens eventually is you get what looks like corrosion, and it pulls little pieces of the metal apart and deposits them someplace else. So then you can actually get pinhole leaks in your radiator and your heater core, or even start eating away at the heads or the head gaskets themselves.
Okay. Let's see how we would test for this.
It's pretty easy to test, but it's a test that's often overlooked by most technicians. And I'll show you, it's very easy. You take a multimeter, and it can be any multimeter with a 12-volt scale. It doesn't have to be fancy, pretty basic like the one I have here. And what we're going to do is we're going to look at that scale, and I'm going to take the negative battery terminal, probe, and put it on the terminal there. I'm going to take the positive, I'm going to dip it down inside the coolant. I'm not going to try to touch the sides of the radiator or anything like that. I'm just going to put it right in the coolant itself. And we can see here that the scale actually went up to almost 0.2 volts. Now, that's a little higher than I like to see it. In fact, it's about double. I like to see it no more than 1/10 of a volt. So this could actually have a problem with electrolysis. Interesting, though, that nothing's on the system. So this is just sitting. If you would turn on the headlights and maybe some of the accessories,
okay,
and then we'll see if that makes a change.
Okay, let's have a look.
Okay, why don't you go ahead and bump the starter a little bit too, and I'll check for that.
Okay.
Okay, yeah. We're really not seeing very much change here. So what I think the situation is here is the coolant's probably just old, and we've got a situation where it's starting to lose its effectiveness for protecting against electrolysis. Okay. Another issue we want to talk about is the pH balance of the coolant itself. You know, if you've ever been around a pool or a hot tub, everybody checks the pH level of their tubs and make sure that the chemicals are okay in the system. Pretty much the same way in here. And we do that a couple different ways. We can check with a pH meter that's digital. And we get a reading of 8 to 9 points, which is pretty acceptable. If we get over 11 or way under 7, we want to be concerned, because what happens is we have either a too acidic mixture or we have too alkaline of a mixture, too base. And we can also check that with test strips. Test strips are really easy to use. You just dip them in the coolant. You let them sit for a minute. And then you compare them on the scale on the
Oh, I can see.
jar.
Yeah, you just match it up there.
Yeah, just match it up. Now we can see here that it agrees with our digital meter that it's about in between 8 and 9 there. So it's pretty accurate. The thing we want to be concerned about with pH balance is that we maintain a proper level over time. It's very critical to get the chemistry right in your cooling system. And things that can change that cooling system and the effects are pretty drastic. What happens is if we get too acidic of a mixture, you'll start eating hoses, you'll start eating the brass and copper and the aluminum of the engine.
That doesn't sound good.
Oh, it's not good at all. It'll tear up. All of a sudden you'll have leaks inside your vehicle because your heater core is melting apart. And how this happens is you can get air mixed in the system, and it will cause that mixture to become acidic. or if you get combustion gases in the coolant itself, it'll become very acidic. In fact, it'll be more like sulfuric acid, and we know that's not good for the system at all. But the other side of the coin there is that it becomes too alkaline, too base. And what people don't realize there is that when that happens, there are certain chemicals that we put in the coolant to maintain the lubrication and the cavitation protection, and then also just to maintain coating the systems, protect them. And if that mixture becomes too alkaline, those floating mixtures will fall out, and what they do is they get sediment involved in there. And the sediment will get clogged in the radiator, clogged in the heater core, clogged in the passages. In fact, I've got a radiator here I can show you.
Oh yeah, I'd love to see it.
Here's one that I cut off, and you can see that all the sediment that's been involved in there. Now, this isn't necessarily only from being too alkaline. This can also be from having tap water mixed in with the coolant, which is also very bad.
I've always used tap water.
A lot of people do. A lot of shops do too. But the thing is, we always want to add distilled water or deionized water in with the coolant.
Or else that's what happens?
Or else this is going to happen over time.
Oh boy.
So there's another issue. We can prevent a roadside breakdown. Well, I got one more radiator to show you here. I cut this one apart just the other night. And you can see it's a little different color, but it's still the same kind of sediment. It's very hard too. If you poke at it, it's not soft.
No, it's really not.
It's calcium and lime. That all comes from that tap water. And it also comes from the mixture being too alkaline. Now that I've already done that, and I've tested for the pressure in the system, now I can remove this, and we want to not forget about testing the cap itself.
That's a good point.
Because the cap is what maintains the pressure on the system. We have different adapters also for pressure testing the caps. Now the cap does two things. It pressurizes the system and keeps that pressure maintained, but it also vents it to keep it from overpressurizing. So if it gets over 18 pounds, it's going to bleed a little pressure off. Where's that pressure going to go? It's going to go to the overflow system. The overflow system keeps the vehicle from sucking air back in, because after it cools off, now we're going to bring in the coolant that was stored there, and it'll keep that going. So I'm going to put this cap on our little adapter. I'm going to hook the pump up to it. Nice tight seal. I'm going to pump it up, same pressure, because I want to see what happens here. Now you can see I'm trying to pump more, but it's not going up anymore. It's stopping about 18 pounds.
So it's venting that pressure that you talked about.
It's venting that pressure, but actually it's venting a little bit low. It's only holding at 15 pounds.
Oh.
So this cap probably needs replaced. Now, a lot of people think 3 pounds, that's not a big deal. That's 9 degrees. So in the middle of summer, when you're driving down the interstate with your air conditioning on, all of a sudden you get stuck in traffic. 9 degrees can be a big deal.
Oh, definitely.
And that can cause one of those roadside breakdowns. So this cap probably needs replaced. And you can see on the seal there, you can see a little line worn into it. It's grooved. So that can cause some of those leaks. And one more thing, we're talking about caps. Remember I was saying it does a couple different things. Not only does it keep it from overpressurizing, but it brings that coolant back into the radiator.
I remember you mentioning that.
Yeah, well here's how it does it. There's a little valve on the bottom of this cap, and it's a vacuum valve, and it's just gravity fed. And when vacuum starts being drawn in by the system by it cooling off, now it'll let the coolant be drawn in through this area and then back in through this valve. The thing is though, they've been experiencing an awful lot of problems with some of the new coolants, like some of the organic acid coolants, and they're very susceptible to contamination. Well, one thing they've discovered, and General Motors actually came out with a technical bulletin about this, is that this vacuum valve actually allows contamination to be trapped inside that vacuum valve, and then it won't close.
I can see how that can happen very easily.
Yeah,
It's a very small space.
Yeah, very small. So what happens now is that it doesn't build the proper pressure and doesn't use the proper vacuum, and it loses that ability to suck the coolant back in. So here's a way to fix that. There's another kind of cap, and we make this, and it actually is spring-loaded.
Oh, I see that.
So now that when you pull this down, and say there's some contamination around there, it's always going to stay shut until it actually starts to bleed a little vacuum in. So that's a great way to keep that contamination out. Again, you can prevent a roadside breakdown because we want to keep that system as full as possible.
Yeah, I think a lot of people don't realize something as simple as a radiator cap can, be the difference between, being stranded on the side of the road.
And I'm amazed, when I had my shop, there are so many vehicles out there running around with bad radiator caps on them. Virtually half the vehicles I checked had bad radiator caps. It's not an expensive item, but it's one that should be checked every year at least and replaced.
It's great to know.
Yeah. The other thing that we're going to want to start doing is when we look at a vehicle and we want to prepare it for service, we want to make sure there's no leaks in the system. And one way we can do that is by pressure testing that system with a pressure tester.
Is there a neat tool that's available for
Sure,
this?
sure. We've got a tool here. And basically it's just a hand pump. And it's got a scale on it. And the scale shows us that we can simulate the pressure that's operating on the system. Now, I don't know if you realize there's pressure on this system at all times for a reason. For every pound of pressure that we put on the cooling system, we can increase the boiling point by 3 degrees Fahrenheit. It's just like a pressure cooker on the stove. Mm-hmm. Well, now instead of operating at 212 degrees, now we can operate by putting 15 pounds of pressure on. Now we can go up to 230, 245 degrees and not boil over. And that's a much better situation to have in the middle of summer.
Oh, definitely.
Yeah. So I'm going to use this, and basically we're going to simulate the exact pressure that operates on this system. And we have several different adapters for this tool, but this particular radiator doesn't need an adapter. It just uses the straight adapter that comes with the tool.
Just screws right on.
It screws right on. Now it's nice and solid. We've got a nice seal there. Now if I look at the cap, I can see here that this is an 18-pound system.
Okay.
So I can go ahead and pump this up. There. Now I'm just about at 17 pounds. I can go ahead and pump it up a little more. I like to pressure test them a little higher than what they're rated at. That way we know if there's any leaks. Now I can look at the scale there, and it's holding pressure. And this should hold for a minimum of 2 minutes. I like to see them hold for all day long if I want to. But immediately when I do this, there's already fluid in the system. So if there's any leaks, I can look underneath the vehicle and see if anything's dripping out.
Plus, wouldn't the dial be slowly going down?
The dial would be slowly going down. Yeah. Now, it's interesting though, sometimes I get a leak that doesn't leak out on the ground. It doesn't leak out inside the car where the heater core area is, but it's actually leaking, say, inside the radiator or inside the engine compartment.
Really?
It can leak into a cylinder and you got a little head gasket leak or an intake leak. Or you can actually get them on automatic vehicles. There's a transmission cooler inside. Well, if the transmission cooler gets a hole in it and I pressurize the cooling system, now I can see that leak going into the transmission oil cooler. But it's hard to see, so now I got to start looking around to see where that coolant's going. And there's various tests that we can do that. And there's some articles that we've written that say how to test for those different issues. But we can see that this system doesn't appear to have any leaks.
It seems to be holding steady.
It is. Now, there's an interesting point, and I like to tell people about this tool, that this isn't actually the only thing you can use it for. One of the big issues with vehicles today is getting the air out of the system. And air in the system is real bad because it causes a number of problems, corrosion and hot spots. And we'll get more into that in a minute. But with this particular vehicle, there's no bleeding screw or anything with it. But you can feel how hard this is pressurized right now. It's just like it would be, driving down the road. Feel how hard, there's a lot of pressure on this system. But I like to use this tool when I'm doing maintenance to finish bleeding the air out of the system. And if there was a bleed screw on this vehicle, I could just go ahead and crack that bleed screw open at the moment.
To force all the extra air out?
Force some air out. I'd pick a high point on the vehicle. This one doesn't have a bleed screw, but I can tell you what I can do is I could probably crack this little clamp open here and bleed some of that air out. Hear it?
I can hear it, yeah.
That's all air. I don't see any coolant coming out. There, now we're starting to get some coolant out. So we bled quite a bit of air out of there,
quite a bit of air in there,
just with that tool. That's a handy little extra tip there. Well, now what I'd like to talk about is refilling the system. We just drained and flushed the system, and what we'd like to do now is refill it to the best of our ability.
Okay.
The problem is, in the past, the way we've always refilled the radiator system is just by taking a container of coolant and a container of water, or maybe a garden hose, and pouring it in the system. Well, first of all, that invites air to be trapped in the system.
And air is not good, I take it.
Air is very bad in the system, and there's multiple reasons. One, and foremost, it probably invites the most amount of corrosion that can get into a system. If there's no air in the cooling system, it can't corrode, it can't rust, unless you're just using straight water, and that would also invite it. So we have to have a mixture of coolant. We want to have 50% coolant, and we want to have 50% distilled water. We don't want to use tap water. But the reasons, again, that air is bad, not only for corrosion, is that it also creates hot spots, steam pockets, and air that gets trapped up around the thermostat is going to keep the thermostat from operating properly, because it takes a much higher steam temperature to open that thermostat than it does water or coolant temperature around that thermostat itself. And you know, there's lots of pockets around here in the engine, and all of those pockets are very difficult to get all the air out of, because as you start filling the system, it fills up from the bottom. So it starts filling up from the bottom, and the liquid raises up, and then it just traps air up in the top portions. Well, these kind of engines aren't nearly as bad as some of the front-wheel drive engines and vehicles that may have rear heater cores as well. Heater cores that may be up higher than the engine, or heater cores that are way in the back that maybe have some traveling routes for the coolant that has to get back there in the plumbing. Those are very easy to get water or air trapped in as well.
So is there a way that we can fill this up to capacity while removing all the air?
Actually, there's a fantastic tool that we have, and it's called the airlift. And the airlift tool, what it's going to do is it's going to draw a vacuum on this system. And it's going to create a lower pressure system over there than it is out here. And then that way we can open a valve and fill it back up with coolant to 100% capacity. There won't be any air trapped in the system at all.
That sounds great. Let's see how this works.
Okay. Well, here's the tool. And basically, it's got a cone-shaped design on it, and that fits in every kind of radiator neck there is.
So you would never need an adapter, would you?
I don't need any adapters. It will fit these kind of vehicles. It'll fit heavy trucks. This will work on everything, big or small. So what I'm going to do is I'm going to use shop air to create a vacuum on this system. So reach over here, grab my air. I'm going to hook up my quick disconnect. And you can see it's starting to draw a vacuum on the scale. And look at these hoses, Mark. See them starting to shut and close down? That's because we're drawing a good vacuum on this system. Now this isn't used to evacuate the coolant itself. We're just getting rid of the air at this point. We've already drained the system. Great. Just that quick, we've got a full vacuum on the system.
You can see these hoses are completely collapsed now.
Yeah, now what you'll notice here also, Mark, is that this is another pressure test. So we're also checking the system for leaks right now as well. We can see here on the scale that this isn't moving at all. So we know that the system is not leaking anywhere as well.
Should we be concerned about how these hoses are collapsed? Could this possibly damage them?
This isn't going to damage the hoses, but one thing you might want to watch out for is if you're dealing with a hose that's very old, you might hear it cracking, or it might get very, very deformed shape right up against the edge of the connection. Then you know maybe you've got a little weak point there in the hose. But this is going to be just fine for the hose. It'll expand out right back to normal. So now we can take that off. It's holding vacuum. And by the way, that pressure, the vacuum test is very effective for finding even very small leaks on heater cores even, and head gaskets as well. Now, what we need to do first of all is we need to mix up some coolant.
Okay.
So let's do that briefly. And what I'd like to do while I'm talking about the coolant here is we're going to mix this 50-50. And like I just said a minute ago, we want to use distilled water. Distilled water is very important. And the reason is because tap waters contain too many minerals and deposits, and they're going to clog up your radiator and your cooling system. Those deposits will get into your engine compartment, their heater cores, and it'll just cause you a lot of expense down the road. So it's always best to use distilled or deionized water when you're trying to take care of your cooling system. I've got a couple of radiators over here that I can show you. Now here's an example of what happens when you use tap water. See all these mineral deposits inside here? Yeah, that's very bad. That'll clog up a system and you'll lose a lot of your cooling capacity. Did you know that a 1/16 of an inch of scale and deposit on an engine surface you're trying to transfer heat from is equivalent to trying to transfer heat through about 5 inches of cast iron?
Wow.
Yeah, and you can see the rest of this radiator. It's not in real good shape either, and still, this is also from corrosion. All along the edges, both sides here, you can see how terrible it's been to have all that corrosion inside that system. So there again, that's another roadside breakdown waiting to happen. Okay, now we've got our coolant mixed up here. We've got a 50-50 mixture, distilled water and ethylene glycol. I'm going to mix that up. Now we're going to hook this hose up to this tool. And the first thing you're going to notice here, Mark, is that there's air trapped in this hose. So the very first thing that I'm going to do is I'm going to suck 40 cc's of air back into the engine.
And that you just sucked all the air out of.
That's exactly the thing I was trying to avoid. Now 40 cc's is not that much, but I'm going to show you how I can quickly eliminate that. Once I pre-fill this hose up, I'll just draw a new vacuum on this and it'll only take me a few seconds. Watch how quick this fills up. I'm always amazed with this. Watch how fast this coolant will get right up to the top of this hose. I'll crack this one open here. Boom.
Whoa.
Isn't that fast? Okay.
Less than a second.
Yeah, very quick. Okay, now I've got this disconnected. I'm just going to let that sit here for a minute. I'm going to grab my air again. And we're going to draw a new vacuum. We really haven't lost any vacuum on there, but we want to make extra sure that we got all the air out. Just like that, we're up to full vacuum again. Okay, now, in the past, when I've been filling cooling systems, this is something that could take you on a difficult vehicle to bleed air out of. This could take you a half an hour to 45 minutes to fill the system. Because you've got to fill it up, bleed the system, turn on the cooling fans, jack up the car maybe to a certain position, try to get the highest point of that vehicle and bleed air out of it again. This can take a technician, like I say, a long time. And time is money. So I want you to watch. And you can time me if you want. Just how fast this fills up. Okay, here we go. Now you can watch the hoses are going to start expanding. There they go.
Yeah.
I can just watch my scale to tell when it's done. Just like that, we're full.
Well, that was less than a minute.
Yeah. Now, most of the import cars that have done smaller engines, I can fill those up in 20 seconds. Now, to me, that's very valuable because a car sitting in the shop is worth a lot of money to a technician.
Well, that was fast and easy.
Very easy. I won't fill a car any other way now, once I've seen this. Great tool. And we should also say that this will also work with overflow systems. You know, some vehicles don't have radiator caps anymore. We can hook this tool right up to the overflow system and fill it up from there and draw a vacuum from there as well. So that's good to know. Hey Mark, I want you to look at this. Now this is the last bit of coolant that we had. We took the drained coolant and what was remaining of the coolant we didn't use, and when we filled up into our last gallon jug here, you notice we didn't fill up as much as we had to begin with.
No, we've got quite a bit of space here left.
That's in fact how much air was trapped in that engine.
Wow.
So you can just see that by refilling it with a vacuum fill process, just like they do at the factory, we get a much better fill than we would have had if we would have tried to fill it up conventionally.
It's very impressive.
Yeah. Now we're not going to have those slushing noises from the heater core. Our thermostat's going to work better. It's going to be much more efficient at transferring that heat away from the engine.
Great.
Yeah. Mark, I'd like to talk about the overflow system. The cooling system has, on these vehicles, an overflow system. Now, it used to be many years ago, they just dumped that coolant right out on the ground. And what was bad about that was you could fill your radiator to complete capacity, and then as your engine heated up and the coolant got hot, it would expand and flow out of the radiator. Well, then later when it cooled off, it would just bring air back into that system. Well, now we've got air back in the system again, and you want to avoid that. So what they came up with was an overflow system. And the spout on the overflow comes over to this overflow tank. Now when the coolant expands, it fills up this tank, and when it cools off, it creates a vacuum and draws that coolant back in. Keeps the system free of air. But a lot of times people are breaking these spouts off. And when a spout gets broken off, well, then you're just back to the old way, and you're going to fill the system up with air. So what has to happen is if the spout gets broken, is you have to remove the radiator from the vehicle, take it to the radiator shop, have it repaired. They have to put a new tank on the side of it. Well, that's a $300-400 job, or just replace the radiator.
Is there a cheaper way?
There is. There's a new tool. It's called the Tube Medic. And what we have here is a little kit. And I've got a little mock-up of what this radiator neck looks like here. And say we've already broken that off. Well, what we would do is we'd trim off any excess remaining portion of that spout. And then we would take our little kit here, and it's got a drill stop in it that fits inside the neck. We'd place this little drill cutter in a drill, and we drill into the side of this. Now, remember, we haven't removed the radiator. This is done right in the car. And this goes in here, and it drills out any excess remaining portion of that overflow spout, and it puts a nice little O-ring seat on the outside. Once that's done, you can pull out the stop and shake off any debris that you have filled that with. And then you have a little spout kit in here. And the spout kit comes with 3 pieces: an outer spout, an O-ring, and an inner spout. Basically, you just take the inner spout and stick it in there like that. Put your O-ring over it, and then screw on your outside spout.
Well, that's pretty easy.
It's a 5-minute fix. You're down the road. You didn't have to take the radiator out. You didn't have to spend a lot of money. It's done. And it's just a fantastic tool. Before, there was no way of doing this. Now this makes it great.
That is great.
Mark, there's another use for this kit. And say you've got a parts store or a shop where you're selling radiators, and you want to supply a customer with a radiator, but it happens to be the wrong year. Say everything about the radiator is exactly the same, except the spout is facing the wrong direction. Maybe it's in the way of the battery or something. This kit will also relocate that spout. What you can do is you can cut the old one off. And we've got a tap that comes with the kit. And you can tap that location there in the new direction. And then use one of the plugs that's supplied with the kit to then block off that original opening. Now you've sealed it. Now all you have to do is drill a new hole and then point the spout kit in the other direction. And now you can sell that radiator for that vehicle. Okay, Mark, we've got a kit now that repairs these broken overflow spouts. And it's a pretty good tool, and I'd like to show you how it works. These overflow spouts can get broken a lot of times by people leaning on them, or a mild collision, something like that, or it just breaks because of its age. A lot of times when radiators are stored in shops, they can snap them off just in storage too. So this is a great tool. I'd like to show you how it works, and we can break it here live and do one.
Let's have a look.
All right. Well, that was exciting. We broke that off. I'm going to trim off just a little bit of the excess here. And then we're going to use the tool, the little cutter that comes with it.
So you've already loaded the drill bit in there.
Yeah, I loaded that little cutter in there. And what this is going to do is it's not only going to trim out the outside portions of that broken spot, but it's also going to put a nice little O-ring seat in there for our spout. I'm going to put a drill stop in there. That'll keep me from drilling too far, and it'll also keep any debris from falling inside the radiator itself. Okay, you can see I've got a nice little O-ring seat there. I still got just a little bit of flashing. I'm just going to knock off of there. Just like that. Pull out our stop, and you can see it's already caught some of the debris that was on there. So I'm going to knock that off. And then just take the spout kit.
Spout, then O-ring.
Spout, an O-ring, and then the outside of the spout that threads on. We're done. Feel how strong that is.
That's very snug.
Yeah. So that's a great way to replace that without having to replace the whole radiator or, have a car down in a shop for a while.
Great.
Thanks for listening to these cooling system tips from Gates. Remember, when it comes to cooling systems, complete system service is the key. Use the knowledge you've gained today to keep your customers' vehicles on the road and performing well.